Hello everyone, welcome back to our channel. So this is the second part of the space vector. We have already posted a video on the space vector where we have discussed how to convert the given force into the vector form. If you have not watched that video, I will recommend you to watch that video before watching this second part. So in the second part, we'll try to find the moment of a force about a point. So it has two parts. You can find a moment about a point or you can find a moment about a line. If you want a video about the line, you can comment in the comment box. I will try to post a video on that also. So in this video, we will discuss about the how to find the moment of a force about a point. Moment is a turning effect of the force and the unit of moment is Newton meter, that is force into perpendicular distance. We'll break it down how to find the moment. So for that we should have certain steps. So first step is to convert the given force into vector form. Video 1 must watch. So F bar is equal to Fxi plus Fyj plus Fzk. So this is the given force F. The initial point of the force F is A, x1, y1, z1 and the final point is x2, y2, z2, that is B. The second step is to find the moment center. This moment center is given in the numerical, so we'll call it as C. The coordinates are x3, y3, zt. After knowing the center, we'll connect this center with point A. So connect the center with point A. So this is your position vector whose initial point is C and end point is the initial point of the force. So that is RCA. We'll always connect this C with initial point. You can also connect this C with the final point. To make it simple, we'll remember one thing. Instead of remembering many things, we'll remember only one thing, that connect the moment center with the initial point of the force. So this is RCA. So find the vector form of this position vector, that is Rxi plus Ryj plus Rzk. Then take the moment. So we'll take the cross product for the moment. So moment of force F about point C is equal to positional vector cross product of force vector, right? So you might have get confused how to find the cross product, but it is very simple. You should have the knowledge of determinant. So here we can form Ijk parts, then write the Rx part of the position vector, Ry of the positional vector and Rz of the positional vector, and in the last row we'll write the Fx component of the force vector, Fy component of the force vector and Fz part of the force vector. So in this way we can represent the given cross product in the form of determinant. Either you can solve this determinant or you can use the calculator to find out the corresponding moment of the force about point C. We'll see that detail afterwards. So we'll start with one numerical. A force of magnitude 50 kilonewton is acting at a point A 234 meter towards point B 6 minus 2 minus 3 meter. Find the moment of the given force about a point D minus 1 1 2 meter. So here the force magnitude is given 50 kilonewton. So points on the forces are starting point or initial point is A 2 3 4 and the end point is B 6 minus 2 minus 3, and we have to calculate the moment about a point D whose coordinates are minus 1 1 2. So we'll start with the step 1, finding the force vector. So for that we'll use this table. First column will got initial point and end point, then the points magnitude, x y z coordinate and the square root. So final point on the force is B 6 minus 2 minus 3. So this is point B. Initial point is A. So this is the initial point A. The magnitude of the force given 50 kilonewton, mark it here. Put the x y z coordinates of point B 6 minus 2 minus 3. Then for point A 2 3 4. Simply you have to subtract 2 from 6. So it is 6 minus 2, it is equal to 4. Minus 2 minus 3, that is minus 5. Minus 3 minus 4, that is minus 7. So in this way we can easily calculate the value of x2 minus x1, y2 minus y1 and z2 minus z1. I had specially prepared this table format for you so that you will not make any mistake while finding these simple answers. Okay, then we'll find out the square root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. So that is equal to 9.487. So first you have to calculate all those values. You can use the simple format or you can use the tabular format, it is up to you. After calculation of these values, we'll find or we will write the formula for fx. Fx is equal to f into x2 minus x1 divided by square root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. Put the values here. Already calculated. X2 minus x1 is equal to 4. So 50 into 4 divided by 9.487. So the answer is 21.082 kilonewton. Then the next one, Fy. Fy is equal to f into y2 minus y1 divided by square root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. Put the value here, 50 into minus 5 divided by 9.487. The answer is minus 26.352 kilonewton. Then last one, fz is equal to f into z2 minus z1 divided by square root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. So it is equal to 50 into minus 7 divided by 9.487. The answer is 36.893 kilonewton. So in this way we have calculated the three components for the force vector. Now I will put it in the vector format. So f bar is equal to fxi plus fyj plus fzk. So the value of fx is 21.082 kilonewton. The value of fy is minus 26.352 and the value of fz is minus 36.893. So this is the vector form of the given force. Now we'll see alternate method to find out the components of the force vector. So we have already calculated this table. So the next component of the force vector is fx. Fx is equal to magnitude into x2 minus x1 divided by square root of this answer. So fx can be calculated by using these values like 50 into 4 divided by 9.487. So here we get the answer of fx is equal to 21.082. Now the value of fy can be calculated by multiplying this magnitude 50 with y2 minus y1, that is minus 5 divided by 9.487. So 50 into minus 5 divided by 9.487 will give you the value of minus 26.352. Then the value of fz is equal to magnitude into z2 minus z1, that is minus 7 divided by 9.487. So this will give you the value of fz, that is minus 36.893. The equation will be 50 into minus 7 divided by 9.487. So in this way, by using this table itself, you can attach this additional part to that previous table to find out directly the components of fx, fy, fz. You can write the formulas here for respective terms, like fx is equal to f into x2 minus x1 divided by square root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. So this table will simplify everything for you and it will try to avoid the mistakes that you make in the calculation. Generally what you do, you simply, instead of subtracting 2 from the 6, you will subtract 6 from the 2. So such mistakes will be avoided if you use the table format. You can comment it about whether you like this method or you will go with the conventional method, so that it will help me to design particular methods for you. Now we'll find out the position vector. Second point is to calculate the position vector. Now the starting point for the position vector is point D, moment center, and we'll connect the initial point of the force, that is point A. So the position vector is from D to A. So here we'll find out the x2 minus x1, y2 minus y1 and z2 minus z1 for the respective position vector. So we'll use the similar table format. Final point. So final point in this is A. So the coordinates are A are 2, 3, 4. The initial point of this position vector is D. So the coordinates of D points are minus 1, 1, 2. Now we'll find out x2 minus x1, y2 minus y1, z2 minus z1. So it is the subtraction of 2 minus minus 1. So it is 3. 3 minus 1. So it is 2. And at the end z2 minus z1 is equal to 4 minus 2. So it is 2. So simply we can find the values of position vector. So the position vector is 3i 2j plus 2k. Okay, so table format will definitely help you to avoid mistakes in your calculation. But remember, while writing the table format, always write final point first and then the initial point. Then do the subtraction here. We have the value of RDA as well as the vector form of the force. Now we'll find the cross product. Moment of force F about point D is equal to R cross F. Convert it into a determinant format. I, J, K, Rx, Ry, Rz, Fx, Fy, Fz. Now put the values. I, J, K as it is. The value of Rx is 3. Value of Ry is 2. Value of Rz is 2. The value of Fx is 21.082. Fy is minus 26.352 and Fz is minus 36.893. So put the values in the respective places. Now we'll start with solving the determinant. As I have already told you, you can manually solve this numerical or you can use a calculator to find the cross product of the vector. So we'll first see the manual method. So here we'll do cross multiplication. So first consider the I, then consider this part of your determinant. So this is 2 into 36.89 minus sign here, 2 into minus 26.35. This is the first part of your calculation. Then consider J, second part. So it is minus J into, consider this part as well as this part. Cross multiply it. So it is minus J into 3 into minus 36.89 minus 2 into 21.08. At the end, we'll consider the last component of the first row, K. So K into this. So 2 by 2 determinant. So it is 3 into 26 minus 26.35 minus 2 into 21.08. So in this way, we have to cross multiply. First consider the first row, then consider the respective determinant 2 by 2 and cross multiply it. You will get the answer. So by solving this, we'll get the value of moment of point F about point D. So it is equal to minus 21.08, the answer of this calculation, plus 152.8 J, calculation of this equation, and minus 21.2 K. The unit is kilonewton meter. So this is how we can find the moment of the force about any point. First, we have to find the vector form of the force, then find the position vector of that point, then cross multiply the position vector with the given force. So that will give you the value of moment. If you find this video helpful, you can share this video, like this video, and please subscribe to our channel. Thank you very much.